Geometry Chapter 2 review. You may just want to stop this periodically and go back and look and write down how to work the problems. I've already worked it all out, so I won't be reworking the equations, but you can stop the video and write down what you need to. First question says, which choice shows a true conditional with the hypothesis and conclusion correctly identified? Well, what we see here is two different ways they've written it. They've written it, yesterday was Monday if tomorrow is Thursday. And they're saying the hypothesis is tomorrow is Thursday. Well, the hypothesis is going to come behind the word if. If tomorrow is Thursday, hypothesis tomorrow is Thursday. They've identified the correct hypothesis for that one. The conclusion, yesterday was Monday. They've identified the correct conclusion. We have to decide if what they're saying is really true. If yesterday was Monday, then will tomorrow be Thursday? And that's not the case, because if yesterday was Monday, that means today is Tuesday and tomorrow is Wednesday. So we have to mark through that one. It won't work. Part B writes the statement in a traditional version. It says, if tomorrow is Thursday, then yesterday was Tuesday. The hypothesis, tomorrow is Thursday. They've identified the wrong phrase for the hypothesis. That is not the hypothesis. This should be the hypothesis. So this one is wrong. Can't go any further with that one because we know that it's wrong. C says, if tomorrow is Thursday, then yesterday was Tuesday. The hypothesis should be right after the word if, tomorrow is Thursday. And that's not what it says, so we mark through that one as well. Yesterday was Tuesday if tomorrow was Thursday. The hypothesis comes behind the word if, so it should be tomorrow is Thursday. They got that. Yesterday was Tuesday is the conclusion. They got that. Is this true? If yesterday was Tuesday, will tomorrow be Thursday? And that is true. That is answer choice D. Number 2 says, which biconditional is not a good definition? If you can prove it wrong, if you can come up with one instance where it's wrong, then it's not a good definition. A whole number is odd if and only if the number is not divisible by 2. That one's true. That's a good definition. An angle is a straight angle if and only if it measures 180. That one's true. A whole number is even if and only if it's divisible by 2. That's true. A ray is a bisector of an angle. Now, bisector means it cuts it in half. If and only if it splits the angle into 2 angles. A bisector is a ray is a bisector if and only if it splits it into 2 angles. Now, a good definition means that I could write it the other way and it would hold true. If a ray splits the angles into 2 angles, then it's a bisector. That's not the case. A bisector has to split it into 2 angles, and those 2 angles have to be the same measure. So this is the one that is not a good definition. Number 3, how are the 2 angles related? These 2 angles, measures, add up to 180, which makes them supplementary. So this is B. Number 4, 3 over 7x plus 5 equals 8. And I've written that problem right here. And the first step would be to subtract 5 from each side, and that's going to leave you with 3/7 x equals 3. And then you multiply by the reciprocal. I multiplied by 7 over 3 here. I'll do the same over here. And my answer here is 7. Now don't forget, you can check this by putting this in your calculator. 3/7 times 7 plus 5. And seeing if that equals 8. So my answer for number 4 is A. Number 5. Here's problem number 5. It says 6 times 4.5y minus 12 equals 9. And I'll need to distribute. So that gives me 27y minus 72 equals 9. Don't forget to multiply the 6 by 4.5, and don't forget to multiply it by the 12. Then you need to add 72 to both sides. It's going to give you 27y equals 81. Then you'll need to divide. Your answer here is 3. You could also check this one by plugging this in. You could take 6 times 4.5 times 3 minus 12 and see if that equals 9. Okay, 6 and 7 I've already told you aren't going to be on the test, so let's go down and look at number 8. Number 8 says find the value of A and then find the value of the marked angles. These angles are vertical. These are vertical angles. They're across from each other, and vertical angles are congruent. So their measures are equal. So we set up 4A plus 12 equals 3A plus 32, and we need to solve that equation. Angles are either going to be equal to 90, equal to 180, or equal to each other. You need to know the difference. The word complementary means that they are equal to 90. Their sums are equal to 90 when you add them together. Supplementary is the sums of the angles measures is 180. And vertical means they're congruent. So this one is vertical, so it's congruent. We subtract 12 from both sides. We get 4A equals 3A plus 20. Subtract 3A from both sides. A is 20. Well, that's the first part of the problem, that A is 20. Then you have to plug that in. 3 times 20 plus 32, that gives you 92. So the second answer is 92. That is answer choice C. Number 9, solve for W. They give you this formula, V equals LWH. That's length times width times height. And they ask you to solve for W. So you have to divide both sides by LH, and you can do it all in the same step. And that gives you V over LH equals W. So that answer choice is B for number 9. Number 10, identify the hypothesis and the conclusion. Remember, I said hypothesis comes behind the word if, and the conclusion comes behind the word then. So all you have to do is identify those. 11, what is the conclusion of the following conditional? A number is divisible by 3 if the sum of the digits of the number is divisible by 3. Well, the conclusion comes at the beginning because the hypothesis comes behind the word if. So be careful when they rearrange it. But the rule that the hypothesis comes behind the word if is always true. Number 12, what is the converse of the conditional? If a point is in the first quadrant, then its coordinates are positive. All you do is flip that around. If the coordinates are positive, then the point is in quadrant 1. You just flip those two statements around. 13 and 14, I think I told you were removed. So we're at number 15 now. It says, given the measure of angle PQR is x minus 5, I wrote that in, and SQR is x minus 11, I wrote that in, and the whole thing, PQS, is 100, find x. Well, angle PQR plus angle RQS is equal to PQS. That is the angle addition postulate. Then you substitute the values of the measures for the angles. X minus 5, x minus 11 is 100. That's the substitution property. Then from here to here, you combine like terms. It's called simplify. We add 16 to both sides, so it's the addition property of equality. And then finally, we divide. So you'll be asked to supply those properties tomorrow. 16, a very similar problem, except now we're dealing with the entire set of reasons. So we have the orange angle measuring 2x and the blue angle measuring 6 times x minus 3. So angle AOB and angle BOC together make angle AOC. That is the angle addition postulate. Then we substitute the values for the angles. AOB is 2x, BOC is 6 times x minus 3, and AOC is 150. Then we distribute the 6, use the distributive property, combine like terms, that's called simplify, add 18 to each side, so I've used the addition property of equality. If Finally, I divide and I get x is 21. Number 17 tells me that I have a segment from AB that measures 2x, and segment BC is 6x plus 8, and if you put them together you get segment AC, which measures 32. So AB plus BC equals AC. That's the segment addition postulate. We use substitution to replace those segments with their values. Combine like terms, so we simplify. We subtract 8 from both sides, subtraction property of equality, and then we divide, and x is 3. Number 18, what property? Well, from PQ to P minus R equals Q minus R, we see subtraction. So it's the subtraction property of equality. 19, if y equals 3 and 8x plus y equals 12, then, and I went over to the side and I set that up and I solved that equation. And I determined that x was 9 over 8, and that's what went in the blank. 20 says the complement of an angle is 25. What's the measure of the angle? Well, to be a complementary angle, this 25 and the other angle have to add up to be 90. So you take that and subtract it from 90, and the other angle has to be 65. 21 deals with complementary angles. It says measure of angle DFG is x plus 5 and JKL is x minus 9, and it tells you they're complementary, which means that together the two angles add up to be 90. Combine like terms, add 4 to each side, divide by 2, x is 47. But the question said find the measure of each angle. So I've got to plug 47 back in, and one angle is 52 and the other is 38. 21 is a very similar problem, but they are supplementary. So the supplementary means they're going to add up to be 180. So x minus 3 and x plus 61 add up to be 180. We combine like terms. We get 2x plus 22 is 180. Subtract 22 from each side. 2x is 158, x is 79. Again, it says find the measure of each angle. So we plug in and we get 40 and 140. Number 23, we have vertical angles again. So this and this are congruent. So our equation says 7x minus 8 equals 6x plus 11. We add 8 to each side. Subtract 6x from each side, we get x is 19. 24, start, either way, doesn't matter, but to find y, we use the fact that these two lines are supplementary and they add up to be 180. The orange angle and the 4y are going to make a straight line, so they're going to add up to be 180. We solve, we get y is 17. The two orange angles are vertical, so 7x plus 7 is going to be equal to 112. We solve there, we get x is 15. 25 asks us to write the converse of the statement. They just switch it around. If the statement says if x is 4, then x squared is 16. We reverse it. If x squared is 16, then x is 4. Is it true? Well, if x squared is 16, x could be 4, but it could also be negative 4. So this is not a good definition, we provided a counterexample. The converse is not true. I think that takes care of all the problems that are going to be on your exam